welcome. This is module 3. We're going to talk about linked lists. Making this video because some of you were having some challenges around linked lists. And so I thought it was important to demonstrate some video, which I should have did already, so my apologies. Beautiful background. I'm not sure where that's at. It was on my Apple MacBook. That's what they had. I wish I was there, but it's amazing. But anyhow, so let me pull up Adam and bring him over here. Cool. So this week is about linked lists. So let me find a clean tab here. Let's Google something because I don't have anything. Images. All right, let me find a example here. There's so many examples, which look pretty good. We'll go with this guy right here, which is in Wikipedia. Don't know if I can get a bigger image of it. Okay, this is fine. So I think this is actually the thing I have in the lesson, but nonetheless. So basically, what is linked list? It's a linear data structure. So basically, it's an order collection of data. So it's a way to collect data. They're not stored in sequential order where you have 1, 2, 3, 4, and so forth. They're put together by pointers. So let's reverse back. If you had a introduction to C programming class, which we do not offer here at the university, you will learn about pointers and you learn about a lot of different things that you want to learn about, and maybe right off the bat, but it's a good start. So basically, it's put together by pointers. So each node has two things. It has data, which would be this guy right here, and the next guy next to it is a pointer. So it's like, think of it as when you're walking down the streets of Pittsburgh, and you see it often, you see the blind person with a stick. Sometimes you see them being pointed by the dog, and that would be our reference right here. So if you have a service dog walking that person around, then that would be considered a pointer in essence. So the end, which is right here, is called the tail, T-A-I-L. And the end is always null. So there's one property that is the head. So if at this point you've already did GitHub, so you're familiar a little bit with Git, where you have the head of your changes. So it's kind of similar to that, maybe in a sense. We'll have multiple classes. The only property in our class is the head with linked lists. But in our example, we'll set up a class for a specific node, and we'll set one up for a linked list. So right now, I'll just give you guys like a basic example how this works. So let me pull up. We're gonna need terminal. I do have the terminal installed on here, but I'm so used to using this terminal here. So what I did here is I set up a project called linked list. I went out there, that's all, and then I have it right here. So I'm gonna write some code and then use this. So hopefully you can see this. I have a 32-inch screen, so it makes it really nice. But then I had to get used of things being small again, but it's worth it. So I'll call this index.js, and I'll make this larger for everyone. Perfect. All right. So we're just going to do a short amount of code here just to show you how this kind of works, how you can link it together. So we'll come up here. I'll call a constant. I'll call it node1 equals, and then we'll say data. And we'll start off at 4,000 for whatever purpose. And then we'll do this, and then we'll do another constant, and we'll call it node2 equals, and then we'll start this one up to 500, which would be the next one equivalent to it. Okay, and then we want to link the two together. So it's kind of like SQL in a sense. SQL you're doing where, say, a.id equals b.id. So we're going to do no1 dot next, and we're saying, hey, the next person, so think of it as a caboose, think of it as a train. What's the next cart? In this case, we're going to say the next cart is you are it, no2, and so forth. And if you would do it again, you would say node 2. If you had a third one, dot next equals node 3, and so forth. Okay. And then we need to print this out. So I'll do console.log, and then I'll point node 1 out here. Hopefully you follow me at this point. So pretty straightforward. So what I'm going to do up here is I'm going to increase this. I'm going to clear it and make sure I have my code in here. So it is there, so that's good. All right, so I'm going to type in node, and then I'm going to type in the name of the file, which is index, and hit enter. And it didn't work. Beautiful. That's exactly what I was going for. Not to work. You know why? Because I don't think I saved it. Yeah. It would help to save it. So let's try that again. All right. Saving it helps. All right. So as you see here, we start off with 400 and then 500. So it kind of works with the illustration that we showed where you have one branch to the next branch. Well, I say branch, I'm back in a get. But you show how we start off with 400. We're moving to 500. So that's kind of how we start off with it. So this is a basic example of how it works. So we're going to talk about how to insert things. We're going to talk about how to move stuff around. And so remember, the data is, the key here is the data is not sequential. It can be moved around from anywhere. It's like playing a game where, you know, you have that cup and you have that ball in the cup and you move it around a million times and you kept going from side to side. And then you don't know which cup the ball is under. Well, that is linked list. Okay, so bear with me and we'll get started with the exercise. Thank you. So we are going to start from scratch. So I'm going to use the same thing, so you can use this. I'm just going to wipe it out. So what we're going to do here, basic example. I'm not sharing my webcam because the setup I have here is pretty intense. And it gets messy once I pull it up. I'll have to get an individual webcam, so it makes it easier so I can have all the screens. When I have the third screen going, I lose my mouse and I can't find it. So anyhow, going to have a class. So we're going to set up the main class that we've talked about, which is going to be the node class. And that node class is going to represent a way for us to communicate with the data, per se. So we'll have one class that represents each of the nodes that we create, and then when we want to do something with it, we'll instantiate the class. So we'll call the class and say, hey, we want to do this. Can we do it? Yeah, sure, whatever. We have a program. So let's go and get started. And I'll say class node. And then we're going to create a constructor. I'm not sure at this point if you create a constructor or not. In the constructor, if you didn't, let me know and I could go into details with that. So we want to pass in two parameters. We want to pass in the data. And then we want to pass in, which would be, next will be detail, which we talked about is null by default. Okay. Now, this example that I'm showing you is not exactly the same thing that we're doing in the assignment. It's giving you a really good overview, and then I think you'll be able to apply it to the assignment really well. All right, and then we want to pass in this data, which is our node that we're passing in, and we'll say equals data. And then we're going to say this next equals next. And that next would be this guy right here. And I just noticed I made it plural, so let's make it. Am I even recording? Yes, I have to check because one time I went on for an hour and realized I was just talking to myself. Not fun. Because then I forgot what I said. All right, so now we're going to do constant. And we're going to say n1, well, n1. We'll say node 1, like we did before, equals new node. And then we'll pass in the value 100. Okay, so we call it our constant, whatever we want to call it. It doesn't have to be called node 1. It could be called point park 1. It could call whatever you want to call it. And we're creating a new class. So what we're doing is we're calling this class. We're instantiating this class, and we're saying, hey, we want to pass in a value. That value is 100. And we know by default, this value right here is already set for us. We don't have to do anything. Now, if we didn't want to have it set, let's say that it meant something, then we would have to pass in another value here, like 89, for example. But we know that that's not the case. We know by default this is our end and our tail. Okay. Then we'll just print it out, console.log, and we'll print out no one. Simple as that. Save it. Yeah, I'm not gonna make that mistake again. And let me clear my screen because it's a little off. All right, so I'm gonna do node index, and here you go. As you see here, we have our data that we pass in, which is 100, and next is the tail, which is null. Perfect. Does that make sense? Let's hope. Let's move on to the next part, guys. All right, so I went and found an image for a linked list that we could kind of work off of here on the screen, so it'll make a little bit more sense. Since I don't really have an image, I'm trying to beat time here. I'm leaving in approximately less than 2 hours, and I have this video and another video to make, so fun stuff. And then I'm unplugging for a weekend and relaxing, even though still social distancing, so that should be fun. All right, so let's see here. We wanted to create another class, so I'm gonna have another class here. Let's see here. What we'll call it. What we'll do here is we're gonna wipe this out. Well, I'm gonna comment it out so that you know that we did it, and I'll just come down here and create my next class. So I told you we're gonna have 2 classes. One's gonna be for linked list. Another one's gonna be for the node. So we'll say linked list, and we'll do this. So it'll be just like before. So we'll have a constructor right there, and within our constructor we'll have this open close before we pass in values. So we're having something different down here for the linked list. We're going to add some values, so we're going to say this head equals null. So what we're going to do is we're pretending that this guy has no value in it, so that way we allow people, when they want to add data, they can add it into that box. So think of this. Let's see here. I'm really thinking of a good example. I'm staring at a groundhog looking at me. Think of it, you know, as toys collection. People are collecting toys at your company. They have 4 or 5 boxes out, and you put not everybody puts it in sequential order. Some people will fill up one box and go to the next box, or they'll go to one box and see if there's something in there. And that's kind of what we're doing here. We're identifying whether we have to set it up to say, hey, does this, like this right here, does this have a value? Yes or no? So what we'll do is we'll write our codes saying that it has no value. So that way when the person goes to add it in, they'll add it in 1 or 2 spots, but they have to program it as if there's data in there. There's no way for them to identify whether it's in there or not at this time. They have to evaluate and say, hey, if it's in there, I need to put it in the next spot. So that way it's like somebody standing in the line, you can't stand in the same position, or somebody gets on a roller coaster, you can't sit in there if someone's sitting in there. And that's kind of how that works. Hopefully that makes sense. I'm trying to make some good analogies here. All right, so anyways, so we'll set that to null. So that means that this guy will be empty and we'll have no value in there. And then we'll say the size of it equals 0, obviously, because there's no value. Okay, hopefully you follow me at this point. So we have this linked list set up. And then we want to set up different things. And this will be kind of similar to the homework assignment. So this one right here will be insert first node. Oops. And then we'll do insert, I can't type, insert final node. We'll say last node, that's better, last node. It wants to auto sense stuff, and I hate that. Capture the index, so define it. Remove the index. And then we want to clear the list. So we want to do a lot of things, but we'll walk through it slowly here. So where did my mouse go? All right. So the first thing I want to do is insert. So this is where we want to identify whether you know, we have any value. So we'll say insert first, and we'll pass in. We'll instantiate this class right here. So we'll pass in some data. Okay. And then we will do open close brackets, and then we'll say the head. equals what? We'll call a new class like we did before, which is the node. So we're instantiating the class, and we're passing in what? Data. So we're passing in data, and we're referencing, hey, this is the head right here. This is the head that we're going to utilize. So that what that means is, if there is no data in here, which there isn't, it'll pass in data. But let's say that there is data in there. We'll set it up so that it goes to the next one and finds another sequential area. So it needs to identify another pocket in order for it to work. Hopefully that makes some sense. I'm not sure if it does or not, but I hope that it does. So we'll skip down, and we need to print this out. I didn't think about that either. So that would be important if we could at least show what we're thinking here. So let me scroll down here. I got so much going on. Let's go down here and do constant. My linked list equals new linked list, because that's what we have. And then we'll say, you can call this anything. I called it my linked list. You could call it anything you want to. Equals new linked list. So we're calling this class right here. The next thing that we want to do is add the value. So whatever you call it. So I call it my linked list right here. And then I do dot, and then I'm gonna call this method right here. So you could call that also. You don't have to call it instant first. You call it anything. And I'm gonna pass in a value of 100. Okay. And then I want to write it. I want to print it out. So I'm gonna do console log, and I'll do my linked list. Just like that. So I'll have to save it. So the head value is node with the data with 100, and it is null because it's only what picture's next to it. So this should be 100, and then the tail should be 100, but we want the next one to be the next number in order that we want it to be. So in this case, it should be, we'll say 200. We'll go by hundreds. So if you look at the diagram, this is A, but we'll have 100. This one right here will be 200, and so forth, because it's the next one that's in the set, if that makes sense. So what we could do here is we could just come down here and do my linked list dot insert first method, and we can pass in the value 200. Does that make any sense at all? So what we want to do is we want to print the list out. So for this, let's say, you know how like we have, well, we don't have that there, so let's put it down here. We need to do a print list. So let's say print list data. That's what we'll call it. And then we'll say let the current equal this head. Now we're gonna get real fancy with it. And we're gonna say while the current, we'll do a console.log current data, so whatever our current data is. So what we do is set the current equal to whatever the next value is. So it's kind of like a loop through it, just outputting each one piece by piece, if that makes sense. So what we need to do here is we have let current equals the current head, whatever the current head is. We have this going here doing console, but now we need to do current right here, and then equals current next. And then in this case, we could come down here, and instead of writing it out, I'm just gonna spell it out, because to me that's tedious, and we'll just put 300. So we have this new piece of data, we'll save that, and then add another one here, which will be 300, and so forth. So let's save this and run it. And let's see if it works. And yeah, so let's see what we got here. I think I messed up. All right, so I effed up. I want to call this guy right here, which is our print list, instead of the console log. So let's take this guy out. I'll just comment him out for now. And we'll do print list data right there. And oops, wrong one. So we'll do my link list dot call the print list data like that. Let's save that right there. Let's see if this works. That looks better. Before we had it like this. So now you see how it's in order. So it's saying that it starts at 300, 200, and 100. It's going backwards. Why is that? Is that good? Is that bad? So that's right. I mean, that's, so basically the reason that we're getting 300 first is because the last insert first, then we call to the first. So it goes by whatever the last value that was entered in, which was 300, and then it would go to the next value and the next value. So in this case, it would be descending order instead of ascending order, if that makes any sense. So we don't want to insert first. You might want to insert last so you can take care of whatever kind of data is going on. Hopefully at this point it makes somewhat sense of what we're trying to do, and you'll be able to understand the assignment a little bit better. So we want to kind of change some stuff around here. We want to be able to add new methods. Somebody's calling me. Give me a second. Let's see who this is. Beautiful. Someone's calling about my insurance on my vehicle. I don't know if you guys got that one, but that's been going around. I get it all the time, and it makes it look like it's a local number. So I pick up. Beautiful. Anyways, moving on to insert last node. So we'll do insert last node instead of first. And we'll do the same thing as before. We'll pass in some data. We'll do let node equal, new node and data. And then we'll say let current, like that. And then we need to figure out if it's going to be empty. So let's say it's going to be first and last. So let's say if it's empty, then we make the head. We want to make it the head so that if it's empty, we say, hey, this is the head. So what we could do here is we could say if this dot head, and we could say this specifying which data head equals a node, and we could say else right here, and we could say current equals this head. So we evaluate where the head starts at. Now we need a beautiful while loop down here. We'll say while the current dot next, because we don't know what the next is. So we'll do evaluate what the next node is. We'll say current equals current dot next, so that we can evaluate what the next node is, so we can understand it. So we're doing the same thing right here, instantiating our node. Let current if the head equals node, else current equals this head, while the current equals next. So that way it can move on. Hopefully it makes some sense at this point. We're not done, but try to fast forward through here because I have a lot going on. So let's see here. All right, so we need to specify current dot next equals node. Okay. And then we need to capture the size. Size is because any size of a property needs to be incremented. So that's like, any loop needs to know what the loop is. So we'll say this dot size plus plus, so that way it could increment through, and we will not be screwed. So we talked about size, but we didn't put it in there, so that might help if I specify the size. I don't think I did. No, I specified it in the original constructor. So let's see here. What do I want to do? Do it here. So do this dot size right here as well. I think that makes sense. Let me think. You know what? I got that wrong. That'll be wrong because that wouldn't work. So we want to do it in insert up here, insert first. So we have this right here, and then we could do this size plus plus. All right. So we add it to the verse. So we'll increment it at the first so that way we're always incrementing this moving forward. Hopefully that makes a little bit more sense. Let's see, what else can we do here? So let's say that we wanted to add another one, which would be the number value 400. How would we do it? Well, instead of doing insert first at the end, we want to insert, let's say, 400. So we could call the last one. So we could come here and say, my linked list dot insert last, and we'll pass in the value 400. Save it. Oh, looks like I effed up somewhere. Let's see. All right, it's fine. Line 31. Where did I F up at? Probably that size thing. Else. All right, I think. Let's see. What did I do? I ended it. So I effed up. Sorry, I like to use the word F up a lot. Let's see here. So bear with me, gents. I'm here to help you out, and I might need you to help me out. All right, so let me go back and debug what I did here. So I said, if this head, do this head right here, perfect. And then we said, oh, Jesus. No wonder. I'm here to help you out, and I can't help myself out. So we want to say this, else, and I have them backwards. I think there's a term for what that means. All right, so we have this here, current equals head, while current equals that. All right, let's see if that works. All right, so get your curly braces right, which I didn't have them right. Now we insert last, and you see here what it did is it showed what we inserted first, which was what we did last was 300, but since we used the last node, it showed it was last versus first. Does that make sense? So the first was to show you what you did first, and which ones. Well, it went descending, and now we're still doing the descending order, but we're 400 is last. Because if we would have put this in the insert first, then we would have had 400, 300, 200, 100. But we called it last because last is going to be the last part of the node. Okay? Does that make any sense at this point? Maybe I don't have to continue because I've showed you what you need to know. Let's see what is in this week's assignment. This is module 3. It's project, I think. All right, so I'm giving you guys the answers here. Let's see here, storyline marks. All right, so you're doing list append. You're doing, okay, so pretty much a lot of stuff that we're doing here is this, yeah, because you're setting a delete, you're doing it, okay. All right, so a lot of the same stuff. All right, cool. Um, let's see here. So a couple more, and then I'm gonna let you guys figure the rest out. But I think at this point, I provided some really good understanding of this information. Okay, so it's a good start, I think, personally. Do one more. This will be the last part of it. I'm not going to do all this. I think I provided at least a good understanding of it. I hope. I'm going to do insert at the index. And what we're going to do here is each of these values are broken down. So this would be value 0, this would be 1, 2, and 3. So what we're going to do is we're going to pick where we want to put it at, what index. So if we put it, say 3, it'll put it in between. So we want between, well, 2 and 4, whatever. So we had 0, 1, 2, 3. If we put it 2, it put it in between here. So I'm going to show you how to put it in between the index, and I think that will be good because then I showed you how to put it at the beginning, how to put it in, and I showed you how to put it in the middle of it, but I didn't show you how to remove the index. Or I think this will be a good understanding, and it's also because I'm running out of time. So let's see. All right, I don't have that, so we could call it captured index. So this one would be more like insert index. Insert at index. All right, so what we're gonna do here, am I recording, guys? Yes, please tell me I'm recording. Yes, I am recording. And we've been recording for a half hour already. Perfect, so it should be a good video. So I'll do insert at, and we'll say data, and we'll say index. And we'll say if the data is out of range, we've seen that before in like Excel. We'll say if it's greater than 0 and the index is greater than the size, okay, we will then do a return. Okay, then we'll say if the index equals maybe equals 0. So we want to provide some type of value. If it equals 0, then this happens. Okay, so in this case, we'll say this head equals, we want to call the node. Okay, so we want to say this head equals new node, and then we'll pass in data, and we'll pass in the head. So we want it to have value, and we'll do return. Okay, so we're saying if the first index equals, if the head equals the new node, which instantiate the node, and then we say that here's the data, and then whatever data that we're passing in, and then this is the head. Okay, hopefully that makes some sense. So we're kind of doing a lot of the same stuff over and over. So now what I'll do is I'll come down here. I'll set up a constant called node equals new node, and that's data, and we'll let the current and previous. So it's able to evaluate what the current and previous was, so that we can set this in the right spot. Set the current to first. So we're kind of rearranging things how they are, if that makes sense. So we'll say current equals the head, the current head. We'll say that let the count start to 0. Yep. And then we'll do a while loop, and we'll say while the count is less than the index, we'll say the previous equals current. So that's the node before the index. So it allows us to pop it in the right location, so we can pop it right in between. You know what I mean? So if we had it between 1 and 3, we are able to evaluate where that data is going to reside. So we're just practicing how we could push it in the right position, and we can kind of squeeze it in there. So now we'll do a count plus plus, so that we can do a counter, so that it increments. And then we'll say current equals current dot next. So we'll say the current equals the current dot next. So this will be, so this right here will be the node before, so that could be 1, and this would be the node after, and that could be 3, so it would be in between. So hopefully that makes a little sense. And then we'll say node dot next equals current. And let's see here, what am I missing? then we need to have the previous in there. I have to capture that. So we'll say previous. So what was the previous value before? We have to capture, else we'll be in trouble. So we'll say previous next. So what's going to be the next value? Equals node. It's a little twist here, but once you kind of get the thought process of this and mindset of it, it makes it a lot easier, but it takes some time. And then we'll say the current size plus plus, so that we can increment it like we've been incrementing it. Let's see. And then lastly, we need to go down here and add some type of value down here like we've been doing. So we'll do my linked list. And we'll do insert @, because that's what we called it, and we'll pass in 500, for example. And now we need to put the position where it's going to be at. So we'll say position 2. So we pick where we want to identify where we want to put it in at. So we're picking the location. So let's do this first. I'm going to show you something real quick. Oh my God, let's do position 0 real quick. And I'll show you what I mean by that. Because currently, oops, let's do this right here because I haven't saved it yet. It's going to have all this in here. So this is 0, this is 1, 2, and 3. So if we put in position 0, it should be up here in front of that. So let's save it. See, it put it in position 0. So now we're going to put it in position 2. We'll come down here, save it, and now we put it in position 2. So 0, 1, 2. Now we can put in position 4. Put in position 4. Let's see if we put it in position 5, because 5 does not reside. What will happen? Will it work or will it blow up? Well, guess what? It did nothing, because position 5 does not exist, so it just throws it off because we programmed for that so that this would happen and we wouldn't blow up. So we'll put it back in position 2, and there we go. So hopefully this right here, I was going to do more, but I'm running out of time. I think that I provided you some really basic understandings. Hopefully this makes more sense on what a linked list is and how to work on it. If you have any problems, message me. Like I said, I'll be out of town this weekend. I will not be back until Monday. If you have a problem finishing your homework assignment, check it in anyways. Check in your source code. Comment. Allow me to be a commenter, and I'll log in. I can help you out, and then I can have you resubmit. So but do your best. I'll be in an area with 0 phone service, so I will probably not get your message. So thanks for watching, guys. I hope this helps out, and have a nice Memorial Day weekend. Bye for now.